Welcome to viewers and students. Here we will discuss quadratic equation. Now let us recall what we have studied in linear equation in one variable. Say for example, standard form of a linear equation in one variable is ax plus b equal to 0, a not equal to 0, a and b are real numbers, right? Now solution of this equation is x equal to minus b by a, right? Now let us recall what we have studied in quadratic polynomial. Say for example, x square plus 2i's of x plus 1. It's a quadratic polynomial. The degree of the variable is, highest degree of the variable is, highest exponent of the variable is 2. That is why it is called quadratic polynomial, right? And when we make this quadratic polynomial into an equation with right hand side 0, this becomes a quadratic equation. Similarly, say for example, 9x square minus 7x plus say 5. Here degree of this polynomial means highest coefficient, highest exponent of the variable x is 2. So it's a quadratic polynomial. Now if you make it an equation with right hand side 0, this becomes a quadratic equation. Now what is the standard form of quadratic equation? Standard form of a quadratic equation. Quadratic equation is ax square plus bx plus c equal to 0. Here a not equal to 0, a, b and c are real numbers. Why we are saying a not equal to 0? If a becomes 0, this equation will be bx plus c equal to 0. In that case, this will not be a quadratic equation, that would be a linear equation. That is why we are writing a not equal to 0. So a quadratic equation can be expressed in this style, in this format: ax square plus bx plus c equal to 0. Now think about this equation: x square plus twice of x plus 1 equal to 0. If you compare this equation with standard form, this implies you can write it as 1 x square plus twice of x, 2 into x plus 1 equal to 0. Here a equal to 1, b equal to 2, c equal to 1. Similarly, say for example this equation, x square minus 9 equal to 0. Now if you compare this equation with standard form, you can write it as x square plus 0 multiplied by x. Here middle term is not exist, so we are writing as 0 multiplied by x plus minus 9 equal to 0. That means here a equal to 1 means coefficient of x square is a, here a equal to 1, b equal to here coefficient of x, b, here 0, and constant term c equal to minus 9, right? Now let's compare this equation. Say for example, x square equal to 0. Now let's compare this equation with standard form of quadratic equation. This implies you can write it as 1 multiplied by x square, 1x square plus 0 multiplied by x, 0x plus 0 equal to 0. Here coefficient of x square is a equal to 1, coefficient of x is 0, and constant term is also 0, right? So a quadratic equation x square can be compared with standard form of quadratic equation ax square plus bx plus c equal to 0. Now you remember in quadratic polynomial, there are two zeros of a quadratic polynomial. A linear polynomial has only one zero, right? Similarly, a quadratic polynomial has two zeros. Say for example, this quadratic polynomial x square plus minus 1 equal to 0. You compare this polynomial with 0. Now you solve this x square minus 1 equal to 0, x square equal to 1. So what is x? X will be square root of 1. Now square root of 1 will be plus 1 or minus 1. You see, plus 1 square equal to 1 and minus 1 square is also 1. Therefore square root of 1 may be plus 1 or minus 1. That means this polynomial x square minus 1 has two zeros. One is plus 1 and another is minus 1. That means a quadratic equation has two roots, right? So let's try to solve a quadratic equation. Say for example, this is a quadratic equation. Example, x square plus 5x plus, say for example, 6 equal to 0. Now we can factorize this middle term. Say for example, factors of 6, 2 multiplied by 3 equal to 6, 2 plus 3 equal to 5. So let's split the middle term. X square plus 2 plus 3 into x plus 6 equal to 0. That means x square plus twice of x plus thrice of x plus 6 equal to 0. Now you take common from these two. X is common. This becomes x into x plus 3, 2. And here both are divisible by 3. So this becomes x plus 2, 0. Now again x plus 2 is a common factor of these two. X plus 2 common. So this becomes x plus 3 equal to 0. Now product of two polynomials, x plus 2 and x plus 3. These are linear polynomials, right? So product of two polynomials equal to 0. So either this equal to 0 or this equal to 0. So either x plus 2 equal to 0 or x plus 3 equal to 0, right? So x plus 2 equal to 0 means x equal to minus 2. X plus 3 equal to 0 means x equal to minus 3. Therefore, roots of x square plus 5x plus c equal to 0 are minus 2 and minus 3. So we find that a quadratic equation has two roots, right? Now suppose question 1, check whether the following are quadratic equation. Now check whether the following are quadratic equations. Say for example, you are given x plus 1 whole square equal to 2 into x minus 3. Now let's check whether it is quadratic equation or not. Now if you simplify this becomes x square plus twice of x plus 1. How? You know this identity, a plus b whole square equal to a square plus twice of ab plus b square. Now we will compare this a plus b whole square, a square plus twice of a into b, 2 into x into 1, twice x, plus b square means 1 square equal to 1. This becomes twice x minus 6. Now we try to convert this into quadratic equation standard form. Ax square plus bx plus c equal to 0. So let's transpose the terms in the right hand side to the left hand side. X square plus twice x plus 1 minus twice x plus 6 equal to 0. This becomes x square plus 7 equal to 0. This twice x and this twice x cancel each other. So 1 plus 6, 7. Now you can compare this with x square plus 0 into x plus 7 equal to 0. Standard form of quadratic equation. Ax square plus bx plus c equal to 0. Here a equal to 1, b equal to 0, c equal to 7. So it's a quadratic equation. Therefore, x plus 1 whole square into equal to 2 into x minus 3 is a quadratic equation. Right? So it's a quadratic equation. We can convert this into standard form. Ax square plus bx plus c equal to 0. We find that a means here 1, b means here 0, and c means here 7. So let's try out one more example. Say for example, this twice x minus 1 x minus 3 equal to x plus 5 into x minus 1. So let's simplify this. Twice of x into x minus 3 minus 1 into x minus 3. Right hand side, x into x minus 1 plus 5 into x minus 1. Now let's simplify this. Twice of x square minus 6x minus x plus 3 equal to x square minus x plus 5x minus 5. Now this becomes twice of x square minus 7x plus 3, x square minus plus 4x, this becomes 4x minus 5. So let's transpose the terms in the right hand side to the left hand side. Twice of x square minus 7x plus 3 minus x square minus 4x plus 5 equal to 0. This becomes x square minus 7x minus 4x minus 11x, 3 plus 5, 8 equal to 0. So it's a quadratic equation, right? We can compare this with standard form, right? If you compare this with standard form, ax square plus bx plus c equal to 0, here a equal to 1, b equal to minus 11, c equal to 8. Therefore, x square minus 11x plus 8 equal to 0 is a quadratic equation. Right? Since we can compare this with standard form of the quadratic equation, ax square plus bx plus c equal to 0. Right? We can write it as 1 into x square plus bx. B means here minus 11 x plus c 8 equal to 0. Right? Here a means 1, b means minus 11, c means 8. So we can compare this equation with standard form of quadratic equation, ax square plus bx plus c equal to 0. Now let us try out how to form a quadratic equation. Suppose a train travels a distance of 480 km at a uniform speed. If the speed had been 8 km per hour less, then it would have taken 3 hours more to cover the same distance. Find the speed of the train. Okay, so let us try to form a quadratic equation. First, a train travels a distance of 480 km at a uniform speed. Let the uniform speed equal to x kilometer per hour. What is meant by uniform speed? Uniform speed means the train will cover same distance in every 1 hour. Say for example, in 1 hour it is traveling 60 km. That means in first hour it will travel 60 km, second hour 60 km, third hour 60 km, and so on. That is called uniform speed. Therefore, uniform speed is, if uniform speed is x kilometer per hour, so how long it will take to cover the distance of 480 km? Therefore, to cover 480 km, time taken equal to distance divided by speed. This is the time taken, hours. 480 kilometers will be traveled in 480 by x hours. Right? Now it says if the speed had been 8 km per hour less, if the speed had been 8 km per hour less, then time taken would have been 480 divided by x minus 8. If the speed had been 8 km per hour less, 8 km per hour less, earlier speed was x kilometer, so if speed had been 8 km per hour less, that means time taken would have been 480 divided by x minus 8. Now this time taken would be 3 hours more than the earlier time. So earlier time was 480 divided by x. Now this time will be 3 more than earlier time. Right? So if the speed had been 8 km less, time taken would have been 3 hours more than the earlier time. So earlier time was 480 by x hours. So if speed is reduced, new time taken will be 3 hours more than the earlier time. Now let's simplify this. 480 by x minus 8 minus 480 by x equal to 3. So let's simplify this. You LCM x minus 8 into x, this into this 480 x minus this into this 480 into x minus 8 equal to 3. So this denominator becomes x square minus 8x. This becomes 480x minus 480x plus 480 into 8 equal to 3. Now this becomes, if we cross multiply this into this, 3x square minus 24x equal to this into this 480 into 8. Now both sides are divisible by 3, since 48 is a factor of 3. So this becomes x square minus 8x equal to 3 16s are 480, 160 into 8. So if we transpose the term to the left hand side, this becomes x square minus 8x minus 8 16s are 144, 128, 0 equal to 0. So it becomes a linear quadratic equation of this style: ax square plus bx plus c equal to 0. We form a quadratic equation. Now we have to solve this equation. to find the speed of the train. So let's try to solve this by middle term splitting. We will factorize the middle term. We will split the middle term. How? Let's factorize this. 1280 equal to 128 into 10. Now 128 plus 10 equal to 138, and 128 minus 10 equal to 118. So this pair of factors will not help you to find 8. Think another way. Say for example, this can be factorized as 40 into, see, 4 3s are 4 1s are 4 2s are. If you divide this, 4 3s are 12, 4 2s are 8. 40 into 32 equal to 1280. Now 40 minus 32 equal to 8. So we can split the middle term like x square minus 40 minus 32 x minus 1280 equal to 0. This you simplify it like this: x square minus 40x plus 32x minus 1280 equal to 0. This implies x into x minus 40 plus 32 into x minus 40 equal to 0. This implies x minus 40 into x plus 32 equal to 0. So x minus 40 equal to 0 or x plus 32 equal to 0. X equal to 40 or x equal to minus 32. Now speed cannot be negative, right? Therefore speed equal to 40 km per hour. Speed of the train was 40 km per hour. Here after factorization we got x minus 40 into x plus 32 equal to 0. Product of two polynomials equal to 0. So either this equal to 0 or this equal to 0. X minus 40 equal to 0 or x plus 32 equal to 0. Now x minus 42 equal to 0 means x equal to 40. X plus 32 equal to 0 means x equal to minus 32. These two are roots of this quadratic equation. Now we have to find the speed of the train. Speed cannot be negative, so speed of the train was 40 km per hour. Now let's check whether our answer is true or false. Now you see 48 km distance at 40 speed, time taken will be 12 hours, right? Now if speed is reduced by 8 km per hour, 40 minus 8 equal to 32, 48, 480. So what would be the time taken? You see, 16 to the 16 3 the 30, 15. So if speed is reduced by 8 km per hour, time taken will be 15 hours. So that means more than 3 hours than earlier speed. Earlier speed was 40. If speed is reduced by 8 km per hour, that means if speed is 32 km per hour, time taken will be 15 hours. Earlier time taken was 12 hours. So if speed is reduced by 8 km, train will take 3 hours more time to cover the same distance. Now we will try to find a formula for solving a quadratic equation. Now standard form of quadratic equation. Standard form of a quadratic equation is ax square plus bx plus c equal to 0, a not equal to 0, right? This is the standard form of quadratic equation. Now let us try to solve this equation. So let us multiply both sides by 4a, suppose. Now if you multiply both sides by 4a, you find 4a into ax square plus 4a into bx plus 4a into c equal to 0. So this becomes 4a square x square plus 4abx plus 4ac equal to 0. Now let us transpose this term to the right hand side. 4a square x square 4abx equal to minus 4ac. Now you see this is a perfect square, right? Twice of ax whole square. Now you can write it as a product of 2 into twice of ax into b equal to minus 4ac. Now let us remember this identity again. A square plus bx twice of ab plus b square, this equal to a plus b whole square, right? A square plus twice of a into b plus b square, it is a perfect square. We can write it as a plus b whole square. Now you think about this. This is a square, this is twice of a into b. So to make this left hand side a perfect square, we need another term. We need b square, right? So let us add this twice of ax square, 2 into twice of ax into b. So we add b square to the left hand side. If we do so, same thing we have to do to the right hand side. So right hand side becomes minus 4ac plus b square, right? Now you see left hand side becomes a perfect square. A square plus twice of a into b plus b square. So we can write it as a plus b whole square. So here you can write it as twice of ax plus b whole square equal to right hand side equal to b square minus 4ac, right? Now if we want to find the roots of this equation, we have to take square root. Therefore if we take square root on both sides, twice of ax plus b equal to square root of b square minus 4ac. Now square root of a term is either positive or negative, right? Say for example x square equal to 9, suppose. So x equal to square root of 9, that means plus 3 or minus 3. If you square plus 3, then it becomes 9. If you square minus 3, then also it becomes 9. So square root of 9 is plus minus 3. We write it as plus minus 3. So square of this is b square minus 4ac. So square root equal to plus minus this. Now we have to find the value of x. So we transpose the term b to the right hand side. This becomes minus b plus minus root over b square minus 4ac. Now we have to find x. What is x? X equal to, divide both sides by twice a, minus b plus minus b square minus 4ac. This is the solution for x. So we got two roots of this equation. One is minus b plus square root of b square minus 4ac divided by twice a, and another root is minus b minus square root of b square minus 4ac divided by twice a. So these are the roots of this quadratic equation of the standard form. Ax square plus bx plus c equal to 0. The roots will be minus b plus square root of b square minus 4ac divided by twice a, and another root is minus b minus square root of b square minus 4ac divided by twice a. So if you are given a quadratic equation, you can find the roots by using this formula. You have to remember this by heart. So let's try to solve a quadratic equation. Say for example example. Say for example, x square plus 5x plus 6 equal to 0. Comparing with ax square plus bx plus c equal to 0. A equal to here 1, b equal to here 5, and c equal to here 6. Now you see, let us try to solve this by remembering the formula. X equal to minus b plus minus b square minus 4ac divided by twice a. Roots of this equation are this. So if you compare here, minus b means minus 5 plus minus b square means 5 square minus 4 into a means 1, c means 6 divided by twice of a, right? So minus 5 plus minus 5 square means 25, 4 into 1 into 6, 24 divided by 2, minus 5 plus minus square root of 1 means 1 divided by 2. So you get two answers here, minus 5 plus 1 divided by 2 or minus 5 minus 1 divided by 2 plus minus. So this becomes minus 4 by 2 or minus 3 by 2. That means this becomes minus 2 or minus 3. So these are the roots of this equation. Therefore, roots of x square plus 5x plus 6 equal to 0 are minus 2 or minus 3. This is how you can solve a quadratic equation using standard formula. Now let's try to solve one more example using this formula. Suppose question 2, solve this quadratic equation. Twice of x square minus 11x plus 5 equal to 0. Now comparing given equation with standard form ax square plus bx plus c equal to 0. A means here 2, b equal to minus 11, c equal to 5. Now roots of the equation ax square plus bx plus c equal to 0 are x equal to minus b plus minus root over b square minus 4ac divided by twice a. So x equal to minus b plus minus square root of b square minus 4ac divided by twice a. Now what is b here? B means minus 11 plus minus b square means minus 11 square minus 4 into a means here 2, c means here 5 divided by twice a 2 into 2. So minus minus plus 11 plus minus 11 square 121, 4 to the 8 5 is 40 divided by 4, 11 plus minus 121 minus 40, this becomes 81 divided by 4. 11 plus minus 9 divided by 4. So 11 plus 9 by 4 or 11 minus 9 by 4. So 11 plus 9 means 20 by 4. 11 minus 9, 2 by 4. This becomes 5 or half. Therefore, roots are 5 or 1 by 2. Right? These are the roots of the given quadratic equation. Let's check whether it is true or false. When x equal to 5, left hand side equal to 2 into 5 square, 11 into 5 plus 5. 2 into 5 square means 25 into 2, 50 minus 55 plus 5. So 55 minus 55 equal to 0. That means left hand side equal to right hand side. So x equal to 5 is a root of this equation. Now let's check whether this x equal to half is also a solution of this equation. When x equal to 1 by 2, left hand side equal to 2 into x square means 1 by 2 square minus 11 into 1 by 2 plus 5. So this becomes 2 into 1 by 4 minus 11 by 2 plus 5, 1 by 2 plus 5 minus 11 by 2, 5 and half minus 11 by 2, 11 by 2 minus 11 by 2 equal to 0. That means left hand side and right hand sides are same for x equal to half. So x equal to half is also a root of this equation.